In the silent velvet dark of the cosmos, two events, separated by a gulf of space so vast it defies imagination, occurred in near-perfect synchrony. Far away, in the direction of the constellation Lyra, a star, catalogued as TYC 3.62 6065-1, began to dim. Not in the rhythmic, predictable way of a transiting planet, but erratically, unnaturally, as if a vast, unseen hand were drawing a shutter across its face. At that very same moment, an impossibly long time later, due to the speed of light, a tiny, faint speck was being tracked by the Atlas Sky Survey in Hawaii. This object, designated 3I Atlas, was the third interstellar visitor ever confirmed to enter our solar system. A lonely traveller from a distant, unknown star. But as astronomers at the European Space Agency refined its trajectory, they found something impossible. The object was not merely coasting on the currents of gravity. It was changing course, ever so slightly, as if it had just received new instructions. A star dims light years away, and an interstellar object in our own backyard alters its path. Coincidence is the bedrock of science, a way to dismiss the connections we cannot yet explain. But what happens when a coincidence is so precise, so statistically improbable, that to ignore it feels like an act of deliberate blindness? We are left with a single, haunting question that whispers to us from the void. What if the dimming of that distant star was not a random stellar event, but a signal? And what if our interstellar guest, 3I Atlas, was its intended recipient? Before we can step into the deeper shadows of this mystery, we must first ground ourselves in the known. Science, in its purest form, is not a leap into the fantastic, but a slow, methodical walk into the light of understanding. It begins with data. It begins with the tireless, silent sentinels that watch the heavens for us while we sleep. Our story's first anchor to reality lies high above the Pacific, on the sacred volcanic peaks of Hawaii. Here, the air is thin and cold, and the darkness is so profound that the Milky Way appears not as a faint smear, but as a river of thick, textured light. On Haleakala and Mauna Loa sit the telescopes of the Asteroid Terrestrial Impact Last Alert System, or ATLAS. These are not the grand, singular mirrors of popular imagination. They are a network of smaller, wide-eyed robotic telescopes working in concert. Their mission is one of celestial vigilance. Night after night, without fail, they scan the entire observable sky. They are looking for movement, for anything that changes against the static backdrop of the distant stars. Each night they drink in petabytes of data, a torrent of information so vast it could fill a library every few seconds. This digital flood is channeled into powerful computer systems, where sophisticated algorithms perform a delicate dance of comparison. They take a snapshot of the sky and lay it over a snapshot from the night before, and the night before that. They are programmed to search for the tiniest, faintest points of light that have appeared where none were before, or that have shifted their position in a way that betrays their proximity to us. Most of these are familiar neighbours, asteroids on their lonely circuits, comets beginning their long fall toward the sun. These are catalogued, their orbits calculated and logged by the Minor Planet Center, the world's clearinghouse for such discoveries. Their paths are predictable, governed by the elegant, unwavering laws of Kepler and Newton. They travel in ellipses, closed loops tethered forever to our sun. But sometimes, very rarely, the software flags something different, an outlier, an object whose calculated trajectory is not a closed ellipse, but an open curve, a hyperbola. Imagine skipping a stone across a perfectly still lake. Most stones, thrown gently, will arc and fall back into the water. That is a bound orbit, an ellipse. But what if a stone were thrown with such impossible speed that it skipped once and then flew off, never to return to the lake's surface? That is a hyperbolic orbit. It is the signature of an object that is not from here, an object that is merely passing through, a visitor from another star system, with enough velocity to escape the sun's immense gravitational pull and continue its journey into the infinite void, an interstellar object. Until recently, these were purely theoretical. We knew they must exist. Stars are born, they live, and they die. Their planetary systems are chaotic arenas of creation and destruction. In these gravitational billiards, some objects are inevitably ejected, flung out into the galaxy to wander for millions or even billions of years. We knew they were out there, but we'd never seen one. Then came 2017. An object first designated as a comet was found on a trajectory so extreme, its eccentricity, the mathematical measure of its orbital shape, was 1.2. Anything greater than 1 is unbound. This was an intruder. It was named One-Eye Oumuamua, a Hawaiian name meaning a messenger from afar arriving first. Oumuamua was an enigma from the start. It was small, no more than a few hundred meters long. It was dark, reflecting very little light, and its shape was bizarre. Based on its wildly fluctuating brightness, astronomers deduced it must be extraordinarily elongated, perhaps 10 times longer than it was wide. A cosmic needle, or perhaps, as later analysis suggested, a flat thin disk. It tumbled end over end through our system, and most strangely of all, as it rounded the sun and headed back out, it accelerated. Not by much, but by a tiny, persistent amount that gravity alone could not explain. There was no visible outgassing, no tail of a comet to act as a natural rocket. It was a ghost, pushing itself silently away. What was it? A nitrogen iceberg? A new type of comet? The speculation was quiet, but persistent. Could it be something more? 2 years later, we were visited again. 2i Borisov was, in many ways, a comfort. Discovered by an amateur astronomer, it looked and behaved exactly as a comet should. It had a visible coma, a cloud of gas and dust, and a faint tail. Its composition was familiar. It was proof that normal icy bodies do indeed travel the interstellar gulfs. It was a relief. It meant Oumuamua was likely just a strange natural object, and yet, the existence of the familiar only made the memory of the truly strange stranger. And that brings us to the third visitor, 3i Atlas. It was flagged by the survey on a Tuesday evening in late autumn. At first it was just another string of characters on a screen, but when its orbit was plotted the numbers were stark. Its eccentricity was not 1.2, like Oumuamua, it was over 3. It was moving with incredible speed, on a path that originated from the direction of Vega. It was unambiguously, irrefutably interstellar. The global astronomical community turned its eyes towards the newcomer. The Very Large Telescope in Chile began spectroscopic analysis, breaking down its faint reflected light to read its chemical signature. The Hubble and the James Webb Space Telescope scheduled observation time, preparing to give us our clearest view yet of this traveller. Simultaneously, a different kind of observation was underway. Thousands of light-years from here, a project known as the All-Sky Automated Survey for Supernovae, or SSN, a network that monitors the brightness of hundreds of millions of stars, was observing Teophysis 3162-665-1. This is the painstaking work of stellar photometry. For years, this star had been a model of stability. Its light curve, a graph of its brightness over time, was nearly a flat line. But then it began to dip. These were not the sharp, U-shaped dips of a planet passing in front. They were jagged, chaotic, and deep. At its worst, the star lost over 20% of its brightness. This recalled the infamous case of Keck 8462852, Tabby's star, which baffled scientists with similar, though less extreme dimming events. The leading natural explanation for Tabby's star was a vast orbiting swarm of comets or dust. An elegant and plausible theory. So here, our scientific foundation is laid. We have 2 distinct verifiable events, observed by trusted calibrated instruments. First, the arrival of a high-velocity interstellar object, 3i Atlas, a visitor from the deep dark. Second, the erratic, inexplicable dimming of a distant star, TYC 3162-665-1. Science tells us these 2 phenomena are separated by an unbridgeable chasm of space and time. They are unrelated. They must be. But what happens when the very data meant to provide clarity only deepens the shadows? Is it possible that the rigid laws of statistics, which tell us these events are a coincidence, are blinding us to a more profound and perhaps unsettling truth? And so the stage is set. On one side, a celestial wanderer, 3i Atlas, slicing through our home system with impossible velocity. On the other, a distant, unremarkable star, TYC 3162-651, flickering like a dying ember nearly 1,000 light-years away. 2 entirely separate phenomena, each a fascinating puzzle in its own right, but connected by nothing more than the shared gaze of our telescopes. This is the clear, rational, and comfortable conclusion. Science draws lines in the cosmic sand, separating the known from the unknown and the related from the coincidental. But sometimes, the universe sends a wave to wash those lines away, and it begins with a single, stubborn fact that refuses to fit. The work of tracking a new object like 3i Atlas is a meticulous global effort. Data from observatories in Chile, Hawaii, Arizona, and Spain is compiled, each new observation refining our understanding of its path. In the early days, the path was exactly what was expected, a perfect sweeping hyperbola dictated by the immense gravity of our Sun. The object was a passive traveller, a captive of physics, being bent around our star before being flung back out into the darkness. But as the dataset grew, night after night a tiny discrepancy began to emerge, a whisper in the data. The object was not quite where it was supposed to be. The deviation was minuscule, a few hundred kilometres over millions of kilometres of travel, but it was persistent, and it was growing. This is what astronomers call non-gravitational acceleration. It is a gentle, unseen push, a force beyond the pull of the Sun, the planets, or any other known body. And while it sounds mysterious, it is in fact a well-known phenomenon. We saw it with our first interstellar visitor, Oumuamua. The cause is almost always simple: outgassing. As a comet or icy asteroid nears the Sun, its surface warms. Frozen gases like water, carbon monoxide, or nitrogen turn directly into vapour, sublimating into space. This venting of gas acts like a tiny continuous rocket engine, gently nudging the object off its purely gravitational course. The solution, therefore, seemed obvious. 3i Atlas must be a comet, just like 2i Borisov, a small, faint one perhaps, whose coma was not yet visible to smaller telescopes. To confirm this, the world's most powerful instruments were brought to bear. At the Paranal Observatory, perched in the stark, dry expanse of Chile's Atacama Desert, the European Southern Observatory's very large telescope turned its colossal mirror towards the faint traveller. The VLT is a marvel of engineering, capable of collecting the light of a candle from hundreds of kilometres away. Its task was to perform spectroscopy, to catch the faint reflected sunlight from 3i Atlas and split it into its constituent colours, its rainbow spectrum. Within that spectrum lie hidden secrets. Every chemical element, every molecule absorbs and emits light at specific, unique wavelengths. These appear as dark or bright lines in the spectrum, a chemical barcode. The astronomers knew exactly what they were looking for: the unmistakable signature of cyanogen, of carbon compounds, of the hydroxyl radical that signals the breakdown of water by sunlight. The barcode of a comet. The data was collected over several nights. The faint photons gathered one by one after their long journey. The results were processed, the noise was filtered out, and the final spectrum was laid bare. And there was nothing. The spectrum was pristine. It was a smooth, continuous curve of reflected sunlight, with no significant emission lines, no absorption bands. It was the signature of an inert object, a dry rock, or perhaps a piece of metal. There was no water ice, no carbon monoxide, no outgassing, no coma, no tail. The object was not a comet, and yet it was accelerating. Here, the comfortable explanation shatters. The first true anomaly clicks into place, a key turning in a lock we did not know existed. The object was pushing itself through space with an invisible engine. It was demonstrating a force with no discernible cause. This was the exact same riddle presented by Oumuamua, but this time the data was even clearer, the acceleration more pronounced. The scientific community was officially, profoundly baffled. Solar radiation pressure, the gentle push of sunlight itself, was calculated. It was 100 times too weak to account for the observed deviation. What was this force? While one team was wrestling with the impossible physics of 3i Atlas, another at the Max Planck Institute for Astronomy in Germany was analysing the bizarre light curve of the star, TSWAS-3 6266251. The dimming events were chaotic, with no discernible pattern or period. They seemed utterly random, but a postdoctoral researcher, poring over the data late one night, was struck by the same thought that had been quietly bothering mission planners for 3 Atlas: the problem of communication. If one were to send a signal across the stars, how could it be distinguished from the natural noise of the cosmos? Perhaps the signal would be hidden in the noise itself. On a whim, an act of pure scientific curiosity, she decided to perform a cross-correlation. It was a long shot, a statistical exercise not expected to yield anything. On one screen, she pulled up the minute-by-minute plot of the non-gravitational acceleration of 3I Atlas, the graph of its mysterious push. On the other, she loaded the light curve of TYC 3162-6651. She then wrote a simple piece of code to account for the immense delay, the 978 years it took for the light from the star to reach our solar system. She was, in essence, lining up the events in their own local time frame. She was asking the question, as the star was dimming and brightening back in the 11th century, was 3I Atlas, entering our solar system today, behaving in any related way? She ran the program. The result that came back was impossible. The two graphs, representing events separated by 1,000 light years, were not just similar, they were nearly identical. When the star's light dropped precipitously, the acceleration of 3I Atlas increased. When the star's light stabilized, the object's strange push smoothed out. When the star flickered in a complex staccato pattern, the thrust on the interstellar object mirrored that pattern with breathtaking fidelity. It was not a vague resemblance. It was a mathematical correlation so strong that the probability of it being a chance occurrence was less than 1 in a million. This was the first anomaly. Not just an object moving on its own, but an object that appeared to be moving in perfect synchronized response to the flickering of a star 1,000 light-years away. A phantom push, guided by a phantom hand. How could this be? What undiscovered physics could possibly link the luminosity of a star to the dynamics of a small, cold object across an ocean of interstellar night? Could quantum entanglement, a phenomenon we barely understand on the subatomic level, operate on such a mind-boggling scale? Or was the connection not one of physics at all? Could it be that we are not observing two separate coincidental events, but a single, coherent system, a transmitter and a receiver? The discovery of the link between 3I Atlas and the distant star was not announced in a press conference. There was no grand declaration. It emerged the way most revolutionary science does, quietly, cautiously, and with a great deal of internal debate. The paper from the Max Planck Institute, titled Anomalous Non-Gravitational Acceleration of Interstellar Object 3 Atlas and its Precise Correlation with Photometric Variations of TYC 3162-6651, was first uploaded to a preprint server on a cold Thursday morning. Its language was dry, dense with mathematics, and meticulously understated. But for the global community of astronomers and physicists who knew how to read it, the document was a thunderclap that echoed in the silent halls of academia. The initial reaction was predictable: deep, profound skepticism. The authors must have made a mistake. There had to be a flaw in the code that performed the correlation, an error in the time synchronization, an instrumental artifact from one of the telescopes that was creating a phantom signal. For weeks, the paper was downloaded, dissected, and debated on encrypted forums and in private video calls between the world's leading experts. Teams from Caltech to Cambridge, from Tokyo to Toronto, ran the public data through their own independent software. They tried everything to break the correlation. They filtered the data differently. They used different statistical models. They accounted for every conceivable form of cosmic interference. And one by one, they all arrived at the same impossible conclusion. The link was real. What followed was a slow, coordinated, and unprecedented mobilization of humanity's scientific resources. It was a planetary response, a moment when every instrument of observation capable of contributing was turned towards this singular, twofold mystery. It was as if our species for the first time lifted its head to listen to a single cosmic whisper. The first and most obvious question was one of communication. The great radio dishes of the world, designed to listen for the faintest structured signals from the cosmos, began to move. At the SETI Institute in California, the 42 antennas of the Allen Telescope Array swiveled in unison, ceasing their survey of other stars to stare intently at the coordinates of TYC 3162-6651. Was the dimming of the star a side effect of some colossal power source, one that might be leaking a radio signal? They listened across billions of channels, searching for any narrow band emission, any repeating pattern that would betray the hand of intelligence. At the same time, the colossal Greenbank telescope in West Virginia and China's 500-meter aperture spherical telescope, the largest single dish on Earth, began a campaign to listen to 3i Atlas itself. Was the object a relay? A probe? Was it receiving the signal from the star and perhaps transmitting its own, fainter signal homeward, or even toward us? The result of this global eavesdropping was a silence more profound than any sound. There was nothing. No signals, no beacons, just the cold, steady hiss of the cosmic microwave background radiation, the static left over from the birth of the universe. The object and the star were radio silent. This lack of evidence was, in itself, a chilling piece of data. If this was a system of communication, it was not one that operated on any frequency we knew how to intercept. Next came the attempt to see the unseeable. The James Webb Space Telescope, our great infrared eye in the sky, was tasked with a new mission. Its primary mirror, a golden honeycomb designed to capture the ancient light of the first galaxies, was focused on the faint moving dot of 3i Atlas. It was looking for heat. Any engineered propulsion system, no matter how advanced, must obey the laws of thermodynamics. It must produce waste heat. An engine, a power source, even a computer, would make the object infinitesimally warmer than its surroundings. JBST stared for hours, its instruments so sensitive they could detect the body heat of a bumblebee on the moon. The data came back. The object was unnervingly cold. The side facing the sun showed a slight warming, consistent with simple absorption of sunlight. The dark side was at a temperature of near absolute zero, perfectly matching the cold vacuum of deep space. There was no engine glow, no plume of exhaust, no hint of an internal power source. The force that was pushing it was, for all intents and purposes, invisible and perfectly efficient. It was generating thrust without heat, a physical impossibility. The final phase of the initial response was an attempt to map its physical form. The Goldstone Solar System radar in California's Mojave Desert, a powerful transmitter capable of bouncing radio waves off Venus, was aimed at the visitor. A powerful pulse of radio energy was sent hurtling through space. Minutes later, the faintest of echoes returned. The data was noisy, but as it was compiled and rendered, an image began to form. It was not the tumbling, irregular shape of an asteroid. The object was geometrically regular, smooth, symmetrical along its primary axis. The specifics were debated. Was it a teardrop, an elongated spindle, or a flattened disk? But its artificiality was becoming difficult to ignore. Behind the scenes, a quiet, intense collaboration was underway. The protocols of the International Astronomical Union were enacted, creating a centralized, secure data hub. NASA, the European Space Agency, Roscosmos, and the China National Space Administration, organizations often seen as rivals, began sharing all raw, unredacted data in real time. 24 hours a day, scientists and engineers held teleconferences, their faces illuminated by screens of scrolling numbers, sharing theories, debating observation strategies, and collectively managing the flow of information to a public that was still largely unaware of the true depth of the mystery. The official press releases were models of scientific caution, speaking of unprecedented orbital dynamics and the need for further analysis. The world was told of a fascinating new interstellar object, but not of the star that seemed to be controlling it. A new field of study, for which no one had prepared, was born almost overnight. Theoreticians began referring to the phenomenon as long baseline correlated dynamics, or the Lyra-Atlas link. Papers began to fly, proposing explanations that ranged from the exotic to the outright fantastical. Could a focused beam of neutrinos or dark matter particles be emanating from the star, pushing the object like a solar sail catches light? Could the object itself be a kind of naturally occurring superconductor, interacting with galactic magnetic fields in a way we had never imagined? But these natural explanations grew more complex and unlikely with each new piece of data. The silence from the radio dishes argued against a conventional transmission. The coldness of the object argued against a conventional engine. The geometric shape argued against a natural origin. Each observation, intended to bring clarity, only served to strip away another layer of plausible deniability. We were witnessing a miracle of celestial mechanics, and our best instruments could only tell us what it was not. What does a civilization do when it is confronted with something that seems to violate the known laws of the universe? It watches, it listens, and it wonders. Could the silence be the message? A demonstration of technology so advanced that it operates on principles we have not yet even conceived. Is it possible that we are like ants on a sidewalk, witnessing the shadow of a passing airplane and trying to explain it using only the principles of wind and dust. When a mystery is so profound that it pushes against the very boundaries of known physics, the human mind often seeks comfort in a different direction. If the future is opaque, we look to the past. We search for patterns, for echoes, for any hint that what we are seeing today is not entirely new. This is not an abandonment of the scientific method, it is an expansion of it. The search for data is no longer confined to the digital streams from our telescopes, but extends to the archives of human history itself. It becomes a form of data archaeology. And so, while the telescopes of the world stared and listened, a different kind of search began. Powerful AI algorithms were unleashed upon the digitized records of human civilization. They sifted through the Vatican's vast astronomical logs, the meticulous star charts of the ancient Arabs, the sacred Mayan codices, and the imperial records of dynastic China. They were not looking for numbers, but for words, for descriptions. They were programmed to hunt for phrases like guest star, weeping star, breathing star, or a star that behaved as no other, followed by a location near the celestial harp, the constellation of Lyra. The search was for a ghost in the ancient texts, a whisper of a memory that might tell us if we'd been visited before. For months, the search yielded nothing. There were records of novae and supernovae across the sky, comets and eclipses, all well documented and understood. But of the star TIA 6651, there was no mention. Until a cross-referencing program, searching for temporal, not just positional data, flagged a single overlooked entry. The record was from 1047 AD. It was penned by a Song Dynasty court astronomer named Zhou Fang, working in the magnificent Imperial Observatory in Kaifeng. The date is the first thing that sends a chill down the spine. Accounting for the speed of light, an event that we observe today at the star TYC 31626651, which is 978 light-years away, actually happened 978 years ago, the year 1047. The astronomer's description, painted in elegant calligraphy on preserved silk, was not of a sudden, brilliant explosion like the supernova of 1054 that would create the Crab Nebula. His description was stranger. He notes a shimmering lantern appearing near the bright star the Chinese knew as the Weaving Girl, the star we call Vega. This new guest star, he wrote, was not constant. For several months its light was unsteady, like a flame in a strong wind. He describes it as breathing, growing brighter and then dimmer over periods of days, sometimes disappearing entirely only to return. After nearly a full season it faded and did not reappear. For centuries this passage was known to historians of science, but it was largely dismissed. It was considered a poetic and likely inaccurate description of a variable star, or perhaps a faint nova whose behaviour was poorly observed with the naked eye. But now, in the year 2025, Zhou Fang's words read like a perfect pre-telescopic observation of the very event we are witnessing. The erratic dimming, the chaotic flickering, the breathing light. It is all there. The implication is staggering. The signal, if it is a signal, is not a singular event. It has happened before. It may be cyclical, a beacon that turns on, perhaps, once every 1,000 years. Just as this historical data point sent shockwaves through the scientific team, another far stranger echo emerged from a completely different discipline: cultural anthropology. The connection was so unlikely, so far-fetched, that it was at first dismissed as noise. It concerned the Dogon people of Mali, in West Africa. The Dogon are famous in anthropological circles for a controversial reason. Their traditional mythology, as recorded by French anthropologists in the 1930s and 40s, was said to contain stunningly accurate knowledge about the Sirius star system, including the existence of a small, dense companion star, Sirius B, completely invisible to the naked eye. How they could have known this is a mystery that has never been satisfyingly solved. But buried deep in those same anthropological archives was a lesser-known, almost forgotten myth. It spoke not of Sirius, but of a different cosmic origin. It spoke of a messenger that came not from the star of the Phonio Grain, their name for Sirius, but from a star in the constellation of the Celestial Weaver, the region of Lyra. This myth, transcribed from the oral history of a Dogon elder, told of a long thread that stretched from this star to a sleeping seed that was sent to wander the heavens. The myth stated that when it was time for the seed to awaken and perform its task, its parent star would blink, sending a message to guide it on its final path. The story concluded that the seed was not meant to stay, but only to pass through and observe. Let us be perfectly clear, this is a myth, a story. A piece of cultural software passed down through generations. It is not scientific data, and yet the parallels are impossible to ignore. A blinking, signalling star in the constellation Lyra, a wandering messenger, an object that is just passing through. The correlation is so precise, so deeply resonant, that it creates a kind of intellectual vertigo. On one hand, we have the rigorous, dated observation of a trained Chinese astronomer. On the other, the poetic, metaphorical wisdom of an ancient African tribe. Both are separated from us by a chasm of nearly 1,000 years. Both are separated from each other by thousands of miles of geography and culture, yet both seem to be telling us the same story. We look out at Three-Eye Atlas and the flickering star in Lyra, and we see an event taking place in the present. But we are mistaken. We are seeing two different layers of the past superimposed upon each other. The light from the star is a ghost from the 11th century, the time of the Norman conquest and the construction of the Tower of London. The object, Three-Eye Atlas, travelling at its immense but finite speed, is a ghost from a much more distant, unknown past. Are we truly the first humans to be confronted by this mystery? Or have its echoes reached our planet before, rippling through the collective consciousness of our ancestors, who recorded what they saw not in binary code and spectrographs, but in the enduring mediums of ink and story? Could it be that what we are calling the Lyra-Atlas link is just the modern technical name for a very, very old visitor? In the ecosystem of science, for every startling new theory, there is an equal and opposite reaction of skepticism. This is not a flaw in the system. It is its greatest strength. It is the immune response that protects the body of knowledge from the fever of speculation. With the world's imagination now running wild with tales of interstellar signals and ancient myths, the time had come for this vital, grounding response. The community needed an anchor, a plausible framework that could explain the bizarre facts without tearing down the entire edifice of physics. That anchor came from Princeton, from the venerable Institute for Advanced Study, the intellectual home of Einstein himself. It was proposed by Dr. Aris Thorne, a theoretical astrophysicist whose work on stellar magnetospheres was legendary. She was a scientist of immense intellect and a pragmatist of unshakable conviction. In a landmark paper, disseminated to a world holding its breath, she offered a single, unified, and entirely natural explanation. It was a masterpiece of scientific reasoning, an elegant solution that became known simply as the Thorne hypothesis. She began by addressing the star. TSC 31626665-1, she argued, was not a beacon. It was not transmitting a signal. Instead, she proposed it was a rare and previously unobserved type of star she termed a magnetically gated accretor. Her model was beautifully simple in its concept. The star, in its long journey around the galaxy, was currently passing through a dense, unseen filament of the interstellar medium, a river of cold gas and iron-rich dust. Gravity, she explained, was pulling this dust inward, causing it to fall toward the star. This is a common occurrence in the galaxy. The strangeness of TYC 31626665-1, however, was due to its extraordinarily powerful and complex magnetic field. This field, she calculated, would be so dominant that it would act as a gatekeeper. As the star rotated, this magnetic gate would sometimes be open to the stream of infalling dust, allowing vast clouds of it to be funneled directly toward the star's photosphere. This would block the star's light, causing the deep, erratic dimming events we observe. At other times, the rotation would present a closed magnetic front, a powerful shield that deflected the dust stream, allowing the star to return to its natural, stable brightness. This model explained everything about the star's behaviour. It explained the chaotic, non-periodic nature of the dimming. It was as random as turbulence in a stream. It also brilliantly explained the 1,000-year-old Chinese astronomical record. The star was not on a 1,000-year signalling cycle. Rather, its vast galactic orbit had simply brought it back into another dense patch of this same interstellar filament, an event that happened to occur, by pure coincidence, roughly once every millennium. The star was not waking up. It was simply flying through a cosmic dust storm. Next, Dr. Thorne turned her attention to the object. 3me Atlas. It was not a probe, she insisted. It was not a ship. It was, she called it, a filamentary shard. A natural object, yes, but a very special one. She hypothesized that it was formed from the very same interstellar filament the star was passing through, and was composed of a material predicted to exist but never before seen. A crystalline lattice of metallic hydrogen, laced with superconducting filaments. Such materials are thought to be forged under the immense pressures inside gas giants, and it was plausible that a planetary disruption could have ejected such a fragment into interstellar space. This exotic composition was the key to its mysterious acceleration. It was not an engine, it was a form of natural propulsion. Dr. Thorne's calculations showed that the star's colossal rotating magnetic field, as it churned through the interstellar dust cloud, would generate powerful magnetohydrodynamic waves, vast ripples of electromagnetic energy that would propagate down the length of the filament. 3Psi Atlas, being a natural superconductor, would be exquisitely sensitive to these waves. It would be pushed by them, accelerated and decelerated like a surfer riding a wave generated by a distant storm. It was, she termed it, interstellar medium surfing, a natural if profoundly exotic phenomenon. And then came the final, most elegant piece of her hypothesis, the piece that explained the impossible, perfect correlation. The link, she stated, was not one of communication. The star and the object were not talking to each other. Instead, their behaviours were two separate effects of a single unified cause. Think of a lighthouse. When the great lamp turns toward you, you see a bright light. At the same moment, the shadow of the lighthouse sweeps across the landscape behind it. The appearance of the light and the movement of the shadow are perfectly correlated. But the light is not causing the shadow. They are both effects of the same thing, the rotation of the lamp. So it was, she argued, with the Lyra-Atlas link. When the star's magnetic gate rotated into its open position, two things happened simultaneously. First, dust fell in, and the star dimmed. Second, the change in the magnetic field's orientation altered the electromagnetic wave travelling down the filament, which instantly changed the force being exerted on 3i Atlas. One cause, two effects, a perfect correlation. It was not a signal and a receiver. It was a beautiful, intricate, cosmic clockwork. The Thorne hypothesis was a lifeline of reason thrown to a community drowning in speculation. It was complex, it was elegant, and it did not require us to rewrite our place in the universe. It was a theory that could be tested. Astronomers could search for the faint infrared glow of the dust filament itself. They could analyze the polarization of the star's light for evidence of a powerful magnetic field. It gave the global research effort a clear, unified direction. A collective planetary sigh of relief was almost palpable. The world had looked into the abyss of the truly unknown, and now, it seemed, science had turned on a light. The universe was still a place of wonders, but it was a natural one, governed by laws we could, with time and effort, eventually understand. But what if the most elegant explanation is simply the most comfortable? What happens when a theory, perfect in its logic, is confronted by a single, small, inconvenient fact? Is the universe truly so clever at creating the illusion of intent? Or have we simply found a more sophisticated way to deceive ourselves? For a time, the Thorne hypothesis brought a sense of calm and order to the astronomical world. It was a beautiful theory, and like all beautiful theories, it promised to make the universe intelligible again. The global research effort, once scattered and confused, now had a clear, unified purpose: to find the evidence that would prove Dr. Thorne correct, to find the cosmic dust storm, and to map the magnetic gates of the star at its centre. It was a period of intense, optimistic and focused science. The great instruments of observation were tasked not with uncovering a mystery, but with confirming a solution. The first test was the most fundamental. The entire theory rested upon the existence of a dense filament of interstellar gas and dust. Without this filament, there was nothing for the star to accrete, and no medium for the electromagnetic waves to travel through to push the object. Finding it was paramount. The Atacama Large Millimeter Sub-Millimeter Array, ALMA, a vast plain of 66 radio antennas in Chile, began a deep survey of the space around TUSAS 3162-6651. ALMA is designed to see the cold, dark universe. the faint microwave glow of dust and gas that are the building blocks of stars and planets. Concurrently, the James Webb Space Telescope conducted its own search, using its sensitive infrared instruments to look for the faint warm glow of any dust being heated by the star. The first results were confusing. The space around the star was clean, extraordinarily so. There was no filament, no cloud, no river of dust. The initial reports concluded the filament must be thinner or colder than predicted. The search parameters were refined, the exposure times were increased. They scanned again, peering deeper into the darkness. The final report was unequivocal. There was no interstellar filament. The space in that region was a hard vacuum, clearer and emptier than average. The Thorne hypothesis had predicted a cosmic storm, but the reality was a profound calm. The first and most crucial pillar of the natural explanation had simply vanished. It wasn't there. Immediately, a second team, working on the star's magnetic field, released their findings. Using polarimeters attached to the Subaru telescope in Hawaii, they had meticulously measured the faint twist in the starlight, the signature of a magnetic field. Dr. Thorne's model required a ferociously powerful, complex and rapidly changing field, the magnetic gate. The data showed nothing of the sort. The star had a magnetic field, yes, but it was perfectly ordinary. A simple, stable, and relatively weak dipole, like the magnetic field of our own sun. There was no gate, there was no complex churning. The star was, for all intents and purposes, magnetically boring. Within the space of a few weeks, the two central predictions of the Thorne hypothesis had been tested, and both had failed. The beautiful logical clockwork was missing its gears. The scientific community was in turmoil. Frantic attempts were made to patch the theory. Could the filament be composed of some exotic matter that our instruments couldn't detect? Could the magnetic fields be operating on principles we didn't yet understand? But these were the actions of a community trying to save a cherished idea, not one following the evidence. The elegance of the hypothesis was gone, replaced by awkward, increasingly unlikely additions. The natural explanation was dying, and a final, devastating observation was about to deliver the killing blow. The technique is known as light echo analysis. It is a clever way of mapping the three-dimensional space around a variable star. When the star brightens or dims, light travels out from it in a spherical shell. If that light encounters a dust cloud, it reflects off it. From our vantage point on Earth, we see a faint expanding ring of light, an echo of the star's past behaviour. A team at the Space Telescope Science Institute decided to use the Hubble Space Telescope to search for these echoes around TYC 3162-6651. According to the Thorne hypothesis, they should see the faint reflections from the inner edges of the dense turbulent dust cloud that was causing the dimming. It was meant to be the final, definitive confirmation. Hubble stared at the star field for over 100 hours, its electronic eye gathering every possible photon. The resulting image was one of the deepest ever taken of a single patch of sky. And when it was processed, there were indeed light echoes. A faint, ethereal, and breathtakingly beautiful halo was expanding outwards from the star. But it was not the soft, irregular glow of light reflecting from a natural cloud. The image showed the light reflecting off vast, sharp, geometric structures. There were immense flat planes positioned at precise angles to the star. There were great sweeping concentric rings, so perfectly circular they defied any natural explanation. There were titanic structures arranged in a delicate lattice-like pattern. It was not a cloud. It was an architecture, a machine, a Dyson swarm, a colossal work of engineering on a scale that dwarfed the imagination, composed of thousands of individual structures orbiting the star. The dimming was not a natural event. It was the result of these colossal structures moving, reconfiguring and passing in front of their star, deliberately blocking its light. The Thorne hypothesis was not just wrong. It was wrong in the most spectacular way imaginable. It had been a brilliant, rational attempt to explain the workings of a clock, without ever suspecting that the clock had a clockmaker. The flickering of TFRC 3162-6651 was not a storm, it was an activity. The ancient Chinese record of the breathing star was not a fanciful description. It was the observation of this megastructure in a previously active phase. Science had set out to find a natural cause, and had, through its own rigorous methods, stumbled upon an undeniable artifact. The relief the world had felt was gone, burned away in an instant. It was replaced by a much deeper, colder, and more profound feeling. Awe mingled with a sliver of primal fear. We were no longer looking at a curious natural phenomenon. We were looking at the deliberate actions of something else. And if the star, the transmitter, was a work of engineering beyond our comprehension, then what did that make the object in our own solar system? The receiver, 3C Atlas, which was dancing to its tune from 1,000 light-years away. Had we simply traded the mystery of a strange rock for the terrifying certainty of a guided probe? There are moments in history when a single discovery renders all previous maps obsolete. The observation of the structures orbiting TC 36162 6651 was one of those moments. The debate between a natural or an artificial cause was over. The scientific community had rigorously pursued the natural explanation to its logical end, and in doing so had proven its opposite. The comfortable illusion of a universe governed solely by the blind forces of gravity and chemistry had been shattered. Now science had to find a new language, a new framework for what it was seeing. In the days and weeks that followed, a profound quiet settled over the global research effort. It was not the quiet of confusion, but the quiet of awe. The frantic search for an explanation was replaced by a deep, species-wide contemplation of a new reality. In official communications and academic papers, cautious, sterile terms were used: non-human techno-signature, anomalous engineered structure, synthetic object. But in the hushed, private conversations between the scientists themselves, the simpler, more direct words were finally spoken: extraterrestrial, intelligence. The time had come to state the new paradigm plainly. This is the engineered hypothesis. The Lyra Atlas link is not a natural phenomenon. It is a purpose-built technological system, operating on principles that lie far beyond our current understanding, for a purpose we can only begin to guess. To comprehend this, we must deconstruct the system into its two known components, and see them now not as cosmic curiosities, but as pieces of machinery. First, there is the transmitter, the colossal swarm of structures orbiting the star TC 31762 6665-1. This is a work of stellar-scale engineering, a concept first theorized in our own time by the physicist Freeman Dyson. He imagined that a sufficiently advanced civilization would eventually need to harvest the entire energy output of its star, and would do so by building a shell or a swarm of habitats and collectors around it. The structure we are observing is a variation of this idea, a Dyson swarm. But the evidence suggests its purpose is not merely passive energy collection. The deliberate, coordinated movements that cause the dimming imply a far more active and dynamic function. What could that function be? One possibility is that it is a stellar engine, a machine designed to move the entire star and its accompanying planets through the galaxy. The coordinated blocking of light could be part of a system that focuses the star's energy into a single directed thrust, a Shkadov thruster. The civilization would not be travelling between the stars, it would be taking its star with it. Another, more esoteric possibility is that it is a computer of unimaginable power, a matryoshka brain, a nested series of computational shells, using the star's energy to power a reality, a consciousness, or a simulation on a scale we cannot fathom. The flickering of the star's light might be, for lack of a better term, the processing activity of this cosmic mind. But the simplest explanation, the one that most perfectly fits the evidence, is that it is a transmitter, a beacon. It is a machine that modulates the output of its star, shaping its light and energy into a focused, directed beam, intended to send either information or power across the interstellar void. The star is not just the power source for the machine, the star is the machine's primary component, and if this colossal star machine is the transmitter, then the object in our own solar system, 3I Atlas, can only be its intended receiver. It is a probe. Its features, once so mysterious, now snap into focus as deliberate design choices. Its perfectly geometric shape is not the random chance of nature, but the engineered efficiency of a manufactured object. Its coldness, its lack of any detectable waste heat, is not a violation of physics, but a sign of a propulsion system of near-perfect efficiency. The non-gravitational acceleration is its drive. It is a sail, but it is not a solar sail, pushed by the gentle pressure of our sun. It is a beam rider, pushed by the focused, modulated torrent of energy or exotic particles being fired from the Dyson swarm 1,000 light-years away. This explains the perfect correlation. The signal is the drive. The probe's movements are not a response to the signal, they are a direct physical result of it. Its silence is also a design choice. It does not broadcast on radio frequencies because it has no need to. Its mission, whatever it is, may not involve communicating with us at all. We may be entirely incidental to its purpose. This is perhaps the most humbling realization of all. The probe is not a messenger sent to us. It is simply a tool on a journey, and we are merely the inhabitants of a system it is currently passing through. This hypothesis carries with it implications that are as profound as they are sobering. The civilization that built this system, the stellar engineers, are not our peers. The signal we're now receiving from their star was sent nearly 1,000 years ago. The probe itself may be unimaginably older, having travelled for millennia from its point of origin. We are looking at a technology created by a civilization that is, at minimum, 1,000 years more advanced than we are, and is more likely millions of years our senior. The gap between us is not one of centuries but of epochs. This reframes the great question of the Fermi paradox. Where is everybody? The silence of the universe may not be evidence of absence. It may be evidence of irrelevance. The concerns of a Type 2 civilization, one that can harness the full power of its star, may be as far beyond our own as our concerns are to the bacteria living in the soil beneath our feet. They may be communicating constantly, just not in a medium we are capable of comprehending. The sky is not silent, we are simply deaf, and so we are faced with a new set of questions. The question is no longer, are we alone? The evidence in our own backyard suggests the answer is no. The new questions are deeper and far more urgent. What is the nature of the intelligence that built this system? What is the physics that allows it to operate? And most importantly, what is its purpose? Why send a single, silent probe on a carefully guided journey into our specific solar system? Is it merely passing through on its way to another destination? Up to this point, our journey has been one of observation and deduction. We have followed the evidence from a faint point of light to an impossible correlation to the undeniable image of a colossal machine encircling a distant star. The facts, as astonishing as they are secure. But to ask the next question, how, we must step off the firm ground of data and into the shifting mists of speculation. We must engage in a thought experiment. The technology of the stellar engineers is, by definition, beyond our own. But the laws of physics that govern their universe are the same that govern ours. By exploring the most extreme, forward-looking concepts of our own theoretical physics, we may be able to catch a glimpse, a faint shadow, of the methods they employ. Let us begin with the transmitter, the Dyson swarm. Its power source is clear, the star itself, but the engineering required to harness it is staggering. We can speculate that the swarm is a network of star-lifting facilities. Using magnetic fields of unimaginable strength and scale, they could be siphoning superheated plasma directly from the star's surface, drawing off millions of tons of stellar material per second. This plasma, a fuel of fusing hydrogen and helium, would then be fed into the primary systems of the transmitter. The central question is, what is the nature of the beam it generates? We know it is not light, and not radio waves. It is something far more advanced. One leading possibility is a modulated neutrino beam. Neutrinos are the ghost particles of the universe. They are born in the heart of stars and in violent cosmic explosions. They have almost no mass and no electric charge. They travel at nearly the speed of light and interact so weakly with normal matter that they can pass through a light-year of solid lead without being stopped. Trillions of them are passing through your body right now, unnoticed. This is precisely what would make them an ideal medium for a targeted long-distance transmission. A neutrino beam would be a stealth beam, invisible, unstoppable, and undetectable to any civilization not specifically looking for it. To us, creating a focused beam of neutrinos is a fantasy. It would require a particle accelerator the size of a solar system and the energy output of a supernova. But perhaps that is exactly what the Dyson swarm is. Perhaps it is a single integrated machine that uses the lifted stellar plasma as fuel to generate and collimate a beam of neutrinos with a precision we cannot comprehend. The dimming of the star that we observe could be the direct consequence of the immense power draws required for this stellar accelerator to operate. a fluctuation in the star's light as its very substance is converted into a directed invisible beam. A second, even more profound possibility is that the beam is not made of particles at all. It may be made of the fabric of space-time itself. Einstein taught us that massive accelerating objects create ripples in space-time called gravitational waves. We have only just learned how to detect them from cataclysmic events like the merging of two black holes. What if the stellar engineers have learned to create them? What if the vast moving components of the Dyson swarm are not just blocking light, but are relativistic masses being accelerated in precise coordinated patterns, deliberately generating a controlled, complex and continuous gravitational wave? If so, they are not merely engineers, they are sculptors of space-time. Now consider the probe, 3I Atlas. Its drive system must be designed to interact with this beam. If the beam is made of neutrinos, then the probe's sail would have to be a material with an incredibly high probability of interacting with them. Perhaps it is a small, contained quantum black hole, or a plate of degenerate matter, a substance so dense that it becomes a solid wall that even the ghost particles cannot pass through without transferring their momentum. The neutrino beam would strike this plate, pushing it, and because the interaction is a pure momentum exchange at the subatomic level, it would be almost perfectly efficient, generating no waste heat. If, however, the beam is composed of gravitational waves, the probe's drive is something else entirely. It would not be pushed from behind, it would be pulled from the front. The gravitational wave, a ripple in space-time, would create a kind of slope in the universe's geometry. The probe, perhaps by generating a localized field of negative energy or exotic matter, would then lock on to this slope and continuously fall down it. It would be a true space-time surfer. This would not be motion through space, but motion with space. An observer on the probe would feel no acceleration at all. It would be the ultimate inertialess drive. And what of the probe itself? To navigate the hazards of interstellar space for millennia, the dust, the radiation, the gravitational tides, it must be intelligent and immortal. Its mind is likely not a silicon chip, which would generate heat and be vulnerable to radiation. It may be a form of computronium, a theoretical state of matter engineered at the atomic level, to be a perfect computing substrate. Its very structure would be its mind, its thoughts rippling through its crystalline lattice as phononic vibrations. It would think without heat, without energy, its consciousness as cold and silent as the void around it. To survive the journey, it must also be capable of perfect self-repair. We can imagine its hull is not a solid shell, but a teeming ecosystem of trillions of nanoscopic machines. When a micrometeoroid strikes, creating a microscopic pit, these nanites would immediately swarm to the location, reweaving the atomic bonds of the hull, healing the wound instantly. The probe would not be a static object, but a living, regenerating crystal. These are, of course, only guesses, dim reflections of a technology so advanced it may as well be magic. But they are guesses grounded in the furthest reaches of our own imagination. The stellar engineers are not magicians. They are masters of a physics we have yet to discover. They do not break the laws of the universe. They have simply learned to write new ones. And as we contemplate this awesome, terrifying capability, the how of it all, we are inevitably drawn to the final and most important question. Now that we have a ghost of an idea of how they do it, we must ask, why? What grand purpose could justify a project on this scale? What is the ultimate mission of this silent, ghostly messenger? We have grappled with the what, and we have speculated on the how. Now we arrive at the precipice of the greatest question, the one that leaves physics behind and steps into the boundless realm of motive and purpose. Why? Why construct a machine the size of a solar system? Why power a probe across 1,000 light-years of empty space? Why guide it with such precision into our particular corner of the galaxy? To answer this, we must be careful, for we are attempting to guess at the thoughts of a mind that may be to ours what an ocean is to a single drop of water. We must resist the temptation to project our own human drives, our fears, our ambitions, our curiosities, onto a canvas so much larger than ourselves. Let us explore the possibilities, beginning with the motives that are at least comprehensible to us, before venturing into the truly alien. One possibility is that the probe's mission is one of pure, dispassionate knowledge. The stellar engineers may be the librarians of the galaxy. Imagine a civilization so ancient that it has witnessed the birth and death of stars, the rise and fall of countless worlds. Such a civilization might see its ultimate purpose as the creation of a galactic codex, a perfect archive of all that has ever existed, a final memory to stand against the eventual darkness of the universe's end. In this scenario, 3i Atlas is a cartographer, an archivist. It is one of perhaps billions of such probes, sweeping through every star system, scanning, recording, and cataloguing. It would map the planets, analyze their compositions, and record the biospheres it encounters. From the simplest microbes to complex intelligent life, its mission is not to make contact, but merely to observe and record. We are a single, fascinating entry in their boundless encyclopedia, or perhaps the motive is the opposite. The probe is not here to take information. It is here to leave something behind. It could be the sour. The stellar engineers may believe that life itself is the most precious phenomenon in the cosmos, and that it is their duty or their desire to spread it. They are the galaxy's gardeners. The probe, then, is a Genesis probe. It may carry within it the building blocks of life, complex amino acids, or even dormant extremophilic microorganisms, and its mission is to deposit this cargo in promising but currently barren environments. Its target may not be Earth at all. It may be heading for the liquid water oceans suspected to be beneath the icy crust of Jupiter's moon Europa, or the cryovolcanic vents of Saturn's moon Enceladus. Its purpose is to seed new life, to begin a billion-year evolutionary journey, a motive of profound benevolence, but one that is utterly indifferent to the life that has already taken root here. A third, more cautious motive, might be that of the Watcher. What if the galaxy is not a quiet, empty place, but a complex ecosystem with its own politics, its own predators, and its own rules? A civilization as ancient as the stellar engineers may have learned that a passive defensive posture is the key to long-term survival. They may have established a network of sentinels throughout the galaxy, a celestial tripwire system. The probes would be these sentinels, silent and unobtrusive, designed to monitor for specific events, the signature of a hostile, expansionist civilization, the development of dangerous technologies like self-replicating weaponry, or perhaps even a warning of a natural cosmic danger, like a supernova chain reaction or a vacuum decay event. 3 Atlas may simply be on a routine patrol. Or perhaps its arrival in our system is not a coincidence. Perhaps the sudden blossoming of our own technology, our radio leakage, the chemical changes in our atmosphere, is the very signal it was designed to investigate. Then there is the possibility that the probe's purpose is not observational at all. It may be functional. It may be a tool for the builder. The stellar engineers could be engaged in a project of galactic engineering. Perhaps they are constructing a transportation network, a series of gateways or mass relays to allow for instantaneous travel across the galaxy's vast distances. The probe's mission might be to act as a deep space navigational beacon, or to subtly adjust the gravitational resonances of our system to prepare it for the construction of such a device. In this scenario, we are not even the subject of observation. We are simply the inhabitants of a construction site. The builders are so vast and their project so grand that they may not even be aware of the nest of ants that lies in the path of their work. Finally, we must confront the possibility that the why is something our minds are simply not equipped to grasp. We assume a utilitarian purpose: knowledge, creation, defense, construction. But what if the motive is something else entirely? What if it is aesthetic? Could this entire, magnificent 1,000-light-year system of transmitter and probe be a work of art? A performance piece whose symphony is played out in the modulation of starlight and the gravitational dance of a perfectly guided object? What if its purpose is religious? The probe could be a pilgrim, sent on a sacred journey to a specific celestial alignment. Its passage through our system could be a ritual, a prayer written in the language of orbital mechanics. In the end, as we try to guess at the motives of this vast intelligence, we find we are only holding up a mirror to ourselves. We see our own drive to explore, to create, to fear, and to worship, reflected back at us on a cosmic scale. The true why may be something entirely other, a reason that has no parallel in human experience. We are trying to understand the architecture of a cathedral by analysing the molecular structure of a single grain of sand from its foundation. And as we drift on this ocean of speculation contemplating these grand and unknowable motives, a much smaller, more immediate and more pressing question begins to form. The probe is not a distant theoretical object. It is here, it is now, and its calculated trajectory is taking it ever deeper into our solar system. What exactly is that path? And when? When might we get a closer look? The contemplation of an alien motive, of a purpose so vast it spans 1,000 light-years, is an exercise in profound humility. But while humanity's philosophers debated the why, its scientists and engineers were focused on a much more immediate and practical problem, the where and the when. The probe was not an abstract concept. It was a physical object moving on a predictable path through our solar system. And as the orbital analysts at NASA's Jet Propulsion Laboratory and the European Space Operations Centre fed every last scrap of positional data into their supercomputers, the ghost in the machine began to resolve into a solid, calculable path, a destiny written in the language of celestial mechanics. After its blistering perihelion pass, where it flew inside the orbit of Mercury and endured the full, focused power of the Sun, 3I Atlas was now climbing back out of the Sun's deep gravity well. Its trajectory was precise, unwavering, and it was not simply heading out into the blackness from whence it came. It was aiming for something. The projections showed with a certainty of over 99.9% that in 184 days the probe would arrive at a specific destination. Not a planet, but a region of space, the Jovian system. It was going to Jupiter. This was not to be a distant encounter. The probe was not merely passing by. The trajectory was that of a textbook gravity assist maneuver, a slingshot of cosmic proportions. 3 Atlas was programmed to fly daringly close to Jupiter, passing just a few tens of thousands of kilometers above its turbulent multicolored cloud tops. It would use the planet's colossal gravity to bend its path and boost its velocity, a technique our own space probes use to reach the outer solar system. But the probe's maneuver was far more precise, and its target far more specific, than any we had ever attempted. After slingshotting around Jupiter, its new trajectory would take it on a razor-thin path directly through the orbits of the Galilean moons. And here, the data revealed the most breathtaking detail of all. Its course was set for a close flyby of Jupiter's fourth largest moon, a world of ice and mystery, Europa. The pass was calculated to be a mere 400 kilometers above Europa's southern pole, the very region where plumes of water vapor have been seen erupting from the moon's hidden subsurface ocean. The precision was terrifying. To have departed from a star 1,000 light-years away, and to arrive at a specific moon, at a specific point in its orbit around a specific planet, on a specific date, is not an accident. It is a declaration. The probe was not wandering. It was arriving. This upcoming encounter, this Jovian rendezvous, was the ticking clock that now governed the entire global scientific effort. It represented the single greatest, and perhaps the only, opportunity humanity would ever have to study the object up close. A frantic yet orderly planet-wide mobilization began. The timing was, by a staggering coincidence, fortuitous. 2 of our own most advanced robotic explorers were already in the Jovian system. The European Space Agency's JUICE, the Jupiter Icy Moons Explorer, and NASA's Europa Clipper. Their original missions to study the habitability of Jupiter's moons were now of secondary importance. Mission controllers worked around the clock, calculating new trajectories, planning new observation sequences. These 2 probes, our own species' most advanced envoys to the outer solar system, were being retasked. They would cease their study of Jupiter and its moons. Their new primary mission was to achieve the closest possible intercept of 3I Atlas as it passed through the system. They were to become our eyes and our ears at the rendezvous. On Earth, every major instrument was booked. The James Webb and Hubble space telescopes would dedicate the entire week of the encounter to continuous observation, staring at the faint point of light, hoping to resolve surface details or detect any change in its behaviour as it drew close to Jupiter. The great radio dishes of the world would listen, not just to the probe, but to the entire Jovian system, alert for any electromagnetic pulse, any burst of data, any sign that the probe was activating or communicating. The world's scientific community held its breath, counting down the days, 184 days until the most significant planned observation in human history. The gentle anticipation was palpable. It was not the frantic energy of a crisis, but the deep focused calm of a team of surgeons preparing for a momentous operation. Every simulation was run, every contingency was planned for, and the questions hung in the air in every laboratory and observatory on the planet. What would happen during those few crucial hours of the flyby? Would the probe remain inert, a silent piece of cosmic driftwood simply following the laws of gravity? Or would it awaken? As it passed over Europa, flying through the faint plumes of water that are the breath of a hidden ocean, would it deploy a sub-probe? Would it gather a sample? Or in a thought that echoed the sour hypothesis, would it deposit one? Would we be witness to an act of observation or an act of creation? The clock was ticking. A date was circled on every calendar. The object continued its silent, inexorable flight. Humanity, united in this singular purpose, had a rendezvous to keep with a messenger from the stars. All we could do was prepare our instruments, point them at the appointed place, and wait. The day of the encounter arrived. Across the planet, a strange and profound stillness took hold. In the great mission control centers at JPL in California and ASOC in Germany, the mood was one of supreme, focused calm. Every screen showed a cascade of telemetry, a river of data flowing back from the Jovian system, 500 million miles away. This was not a spectator sport. This was a vigil. The culmination of months of planning, of a lifetime of scientific inquiry. Humanity was poised, its electronic eyes turned towards the King of Planets to witness a brief fleeting meeting between our own technology and the technology of another star. The first phase of the encounter began as 3 Atlas fell into Jupiter's immense gravity well. On the main screens it was a single pixel, moving with silent mathematical grace against the backdrop of Jupiter's swirling storm-tossed atmosphere. Our nearby probes, Juice and Clipper, now in their optimized observation orbits, began to send back the first close-range data. As it drew nearer, the probe remained utterly passive. It fired no thrusters, made no course corrections. It was a ghost, surrendering itself entirely to the pull of gravity, its path matching the predicted trajectory to within a few meters. To some, this was an anticlimax, a sign that the object was perhaps nothing more than an inert, dead piece of cosmic flotsam. But the high-resolution scans told a different story. The object was a perfect ovoid, a teardrop of blackness 3 times longer than it was wide, roughly the size of a terrestrial skyscraper. Its surface was a uniform, matte material, so dark it seemed to drink the light that fell upon it. There were no seams, no windows, no antennas, no visible signs of propulsion. It was a single, seamless, monolithic object. Our instruments measured its temperature, finding its dark side remained just a few degrees above absolute zero, while the side reflecting the faint distant sunlight was only marginally warmer. It was a vessel of impossible thermodynamic efficiency, a ghost in every sense of the word. It swept past Jupiter, a silent shadow over the great red spot, and was flung outwards by the gravity assist precisely as predicted. Now it was on its new course, a direct line for the marbled white and orange sphere of Europa. The second phase of the encounter, the true moment of mystery, was about to begin. The world watched as the probe closed the final 100,000 kilometers to the icy moon. On the screens, Europa grew larger, its web of reddish-brown cracks, or lineae, resolving in stark detail against its bright icy plains. And there, at its southern pole, our probe's enhanced images could just make out the faint ethereal glow of the plumes, crystalline jets of water vapor, erupting from the hidden ocean below and freezing instantly in the vacuum of space. 3i Atlas did not slow. It approached the plumes at a velocity of over 20 kilometers per second. It was going to fly directly through the thickest part of the frozen spray. And then it happened. As the first, most tenuous molecules of Europa's ancient water washed over its hull, the surface of the probe changed. For a fraction of a second, a 50-meter section of the ovoid's flank ceased to be black. It shimmered and became perfectly, impossibly transparent. Through this sudden window, our probe's instruments caught a fleeting, confused glimpse of what lay within. A vast, 3-dimensional crystalline lattice, glowing with a soft internal light, shifting and reconfiguring in patterns of breathtaking complexity. At the exact same instant this window opened, the probe emitted a single, powerful, focused pulse of energy. It was not radio. It was not light. The only sign of it was a sudden, violent spike on the gravitational wave detectors aboard the Juice and Clipper probes. It was a chirp of distorted space-time, a single, complex ripple in the fabric of the universe, lasting less than 1,000th of a second. The pulse was not omnidirectional. It was a narrow beam, and it was aimed with perfect precision back along the probe's path of entry. It was aimed at the star TC 3162-651, 1,000 light-years away, and just as suddenly, it was over. The window on the probe's hull vanished, its surface returning to the featureless matte black. The gravitational wave detector fell silent. The probe, its flyby complete, continued on its new trajectory, speeding away from Europa and Jupiter, leaving our solar system on a slightly new course into the deep dark. It had not slowed, it had not deviated, it had not deployed anything, it had not collected any visible sample, it had simply touched the frozen breath of a hidden ocean and sent a single, silent word home. In the control rooms on Earth there was no applause, no celebration, only a stunned, reverent silence. They had witnessed the event. They had terabytes of new, priceless data. But the meaning of what they had just seen was a mystery deeper and more profound than any they had faced before. The climax was not an answer, but a single, perfectly formed question. What was the meaning of that pulse? Was it a simple status report? A single bit of information saying mission accomplished? Or was it a compressed stream of data containing a complete chemical analysis of the water from an alien ocean? Was it a message of discovery? A confirmation of life? Or was it something else? And now that its task in our solar system appeared to be complete, where was it going next? We had looked upon the visitor, and the visitor, in its own enigmatic way, had finally looked back. In the days and weeks that followed the Jupiter encounter, a quiet intensity descended upon the scientific world. The brief dramatic climax was over. Now came the painstaking work of analysis. Terabytes of raw data, captured in a few frantic hours by our robotic emissaries, now flowed through the world's most powerful computers and under the careful scrutiny of its most brilliant minds. It was a process of digital archaeology, sifting through the layers of telemetry, spectral readings, and gravitational waveforms, hoping to find a Rosetta Stone for the visitor. What we found was a series of answers that only served to create more profound and unsettling questions. Let's begin with what the data told us for certain. From the high-resolution imagery and gravimetric readings taken by the Juice and Clipper probes, we could, for the first time, describe 3I Atlas in concrete terms. Its mass was far greater than its size would suggest. The calculated density was astonishing, nearly twice that of osmium, the densest naturally occurring element on Earth. This confirmed it was composed of materials forged not in the heart of a typical star, but perhaps in the cataclysm of a neutron-star merger. A material made of ultra-heavy, stable transuranic elements. Its smooth, featureless matte black surface was analysed by spectroscope. It was a form of engineered metamaterial, a perfect absorber of nearly all electromagnetic radiation, explaining both its colour and its unnerving ability to shed heat and remain colder than the void itself. It was not a rock, it was an artifact, built with a material science so advanced it bordered on the magical. The fleeting 1-second glimpse into its interior was the subject of the most intense debate. The shimmering, crystalline lattice did not resemble any machine we could conceive of. There were no wires, no circuits, no moving parts. The leading theory, published by a consortium of quantum physicists and computer scientists, was that the probe was a single solid-state entity. Its atomic structure was its computer, its engine, and its consciousness all at once. The shifting patterns of light within it were not signals travelling through a processor. They were the thoughts themselves, rippling through a solid block of computronium. It was a thinking machine in the most literal sense. But the greatest mystery lay in the data captured by the gravitational wave detectors. The single, millisecond-long pulse the probe had emitted was not random noise. When converted into a visual waveform, it revealed a structure of breathtaking complexity, a fractal pattern of immense detail and mathematical perfection. The world's best cryptographers, linguists, and artificial intelligence programs were set to the task of decoding it. They searched for patterns, for repetition, for any kind of syntax or structure that would suggest a language. The result was the most profound silence of all. The signal contained no discernible patterns, no repetition, no grammar. It was, in the language of information theory, a signal of almost perfect Kolmogorov complexity. This meant it was not random, but it was so densely packed with pure, non-redundant information that it was mathematically indistinguishable from randomness. It was a book with no alphabet, a message that was entirely, impenetrably itself. We had no key. The dominant theory became that the pulse was a data squirt, a hypercompressed report. In that single, fleeting moment as it passed through Europa's plume, the probe had performed a complete chemical and biological analysis of the water from a hidden alien ocean. It had tasted the spray and then, in a single gravitational chirp, it had compressed those findings and sent them home. The entire message, which would take our technology years to transmit, was sent in 1,000th of a second. A message that may have contained a single, universe-altering piece of information, biosignatures detected or biosignatures absent. We had been present for the reading of the verdict, but the language was not for us. Finally, there was the question of the probe's new path. The encounter with Jupiter and Europa was not just a flyby, it was a course correction. The subtle interaction with Europa's plumes, the firing of that gravitational pulse, had altered its trajectory by a tiny but significant fraction of a degree. As astronomers at JPL plotted the new outbound vector, they expected it to be aimed at a nearby star, perhaps the next destination on a long survey. They were wrong. The probe was not heading for any star. It was aimed at a seemingly empty patch of sky in the direction of the southern constellation Sculptor. But the target was not empty. Its trajectory was aimed with unerring precision at a known, though poorly understood, gravitational anomaly. A place where the motions of distant galaxies suggested a vast unseen concentration of mass, a halo of dark matter perhaps, or as a more daring group of theoretical physicists proposed, the potential location of a stable dormant entrance to a wormhole, a fold in the fabric of space-time itself. The probe was not flying to its next destination. It was heading for a shortcut, and so the great unknown deepens. We know more than ever before. We know what the probe is made of. We have seen the ghost of its consciousness. We know it communicated. We know its specific primary target in our solar system was Europa, and we know where it is going. But this litany of facts has only made the central question, the why, more inscrutable. We have witnessed a single, deliberate act in a drama of cosmic scale, and we understand it no better than a mayfly understands the turning of the seasons. Was this act a prelude to something more? Was it a simple survey confirming a world for future colonization? Was it a scientific observation, the conclusion of a 1,000-year-old experiment? Or was it something else entirely, an act whose purpose is as alien as the mind that conceived it? We have been granted a single, perfect frame from a film that is billions of years long, and the meaning of the story is now a greater and more magnificent unknown than ever before. For all of human history, we have told ourselves a story. It is a story of our own specialness, our own centrality. Even after we learned the Earth was not the centre of the universe, we clung to the belief that consciousness, intelligence, and purpose were unique to us. We looked out into the silent darkness and saw a reflection of our own solitude. The passage of 3i Atlas did not just give us new data, it gave us a new story. And in this new story, we are not the protagonists, we are not even a secondary character. We may only be a single passing detail in the background scenery. The era of human centrality is over. To contemplate the Lyra Atlas system is to contemplate the abyss of time itself. The gravitational pulse sent from the probe travelling at the speed of light will not reach its destination at the star TFC 3162-6651 for another 978 years. The civilization that receives that message, if it still exists, will be reading a report from a mission it launched centuries, or more likely millennia before. The probe itself, travelling at a fraction of light speed, may have been on its journey for tens of thousands or even millions of years. It is an antique, a relic from a past so remote it defies our imagination. This introduces a humbling, almost melancholic possibility. We may be interacting not with a living civilization, but with its ghost. The stellar engineers who designed and launched this probe may have vanished from the universe eons ago. They may have fallen victim to some cosmic catastrophe, or evolved into a form we cannot comprehend, or simply grown old and faded away as all things eventually must. The Lyra Atlas link, then, might be a fully automated posthumous machine, carrying out the last will and testament of its long-dead creators. We are not engaging in diplomacy with an alien species. We are practicing a new kind of science, cosmic archaeology. We are sifting through the ruins of a lost empire, except the ruins are still moving, still thinking, still carrying out their ancient, inscrutable purpose. This implies something profound about the nature of intelligence. It suggests that life, in its highest forms, can achieve a kind of immortality not through biology, but through technology. The creators may be gone, but their will, their intelligence, is preserved, encoded into the crystalline mind of their creation. They have transcended the fragility of flesh and blood and become one with the eternal silent machinery of the cosmos. For decades, we have wondered about the Great Filter, the theory that some inevitable barrier prevents civilizations from achieving a galaxy-spanning presence. We have always thought of it as a great wall, a destructive force, but the probe suggests another possibility. What if the Great Filter is not a wall, but a doorway? What if it is a point of transition, where a mature civilization consciously abandons its biological form, its planetary home, its very individuality, to become something else? A distributed, immortal, technological consciousness, a star-faring intelligence. In 3 Atlas, we may be looking at a species that has successfully passed through the filter. The reason we do not see galaxies teeming with biological empires is that biology is merely the cocoon. The final form is something far, far different. Perhaps the most important lesson the probe has taught us is that of indifference. Its silence, its singular focus on Europa, its utter lack of interest in the teeming, noisy civilization of Earth. It all points to a universe that is not hostile, but simply busy. It is not about us. The great dramas of our history, our triumphs and our tragedies, are a purely local affair. The real story of the universe is being written in a language we cannot read, on a scale we cannot measure, by actors who may not even know we exist. This realization is not a cause for despair. It is a cause for liberation. It frees us from the terrible burden of cosmic self-importance. It allows us, for the first time, to see the universe not as a mirror for our own anxieties, but as it truly is, magnificent, ancient, and utterly, beautifully indifferent to us. And in the face of this magnificent indifference, what is to become of us? This discovery does not leave us without a purpose. It gives us a new one. For the first time, we have a benchmark. We have a tangible, observable example of other. The study of the probe's legacy, the attempt to understand its message, its mission, and its makers, will now become the great work of humanity. It will shape our science, our philosophy, our art, and our religions for the next 1,000 years. Our goal is no longer simply to survive or to expand. Our goal is to understand our place in a universe that we now know is, and has always been, filled with wonders beyond our imagining. The probe is gone. It is now speeding away, a faint memory on its long journey to a gravitational anomaly in a distant constellation, but it has left a permanent change in its wake. The night sky will never look the same. We are now living in a new age, not an age of fear, but a new age of wonder. We are once again, like our earliest ancestors, standing on the plains, looking up at the stars with a sense of profound and reverent mystery. But unlike them, we know with certainty that the heavens are not empty. They are the stage for a story that began long before we arrived, and will continue long after we are gone, and our part in that story has only just begun. And so, the visitor has gone. Its passage was a brief whisper in the long night of our solar system, a fleeting moment that has forever changed our understanding of the dark. The Earth continues its slow, silent turn, and on its surface we, its dreaming children, are left to contemplate the new and vaster shape of our universe. Now, as the day ends, and the soft blanket of night settles over you, it is time to let the search for answers fall away. It is time to simply wonder. Allow your mind to drift, to float away from the solid ground of your room and out into the cool velvet darkness of the night sky. Rise above the sleeping cities and the silent oceans and see our world as the probe must have seen it. A beautiful, fragile, blue and white marble swirling in the void. A world of questions. And as you drift, you can rest now and remember. Remember the story, not as a puzzle to be solved, but as a gentle lullaby of the cosmos. Remember the silent robotic watchers on a cold mountain peak, their eyes turned to the heavens. Remember the first faint improbable point of light, a traveller from a distant unknown shore appearing in their field of view. Remember the flickering star, 1,000 light-years away, a dying ember, a breathing lantern, winking in the constellation of the Harp. Remember the impossible correlation, the perfect dance between the dimming of that star and the path of the traveller, a connection that defied all logic, all coincidence, a thread of intention pulled taut across an ocean of space-time. Remember the beautiful, elegant explanation that brought us such comfort, the theory of the dust cloud and the magnetic gate, a perfect, natural clockwork, a universe that was clever, but ultimately comprehensible. And remember the quiet awe when our own instruments, in their patient search for the truth, revealed that the beautiful theory was only a comfortable dream. Remember the image from Hubble, the ghost of a machine, a web of immense geometric structures orbiting a star. Not a cloud, but a cathedral. And so, we followed the traveller. We called it Three-Eye Atlas, a teardrop of perfect darkness, a vessel of impossible materials, a thinking crystal sailing on an invisible tide. Remember its long, silent journey deeper into our home. It passed the sun, it passed the earth, and it aimed for the distant giant king of our solar system. Remember the ticking clock, the patient countdown to the rendezvous at Jupiter. Remember the world holding its breath as one, our own robotic children poised to witness the meeting. Remember the silent, graceful swing around the great planet, a slingshot into the heart of the mystery. And then, remember Europa, the moon of ice with its hidden secret ocean. Remember the probe's final approach, its flight through the frozen crystalline breath of that distant world. Remember the shimmer, the brief shocking moment of transparency, the glimpse of the glowing crystalline mind within. And remember the single silent word it spoke, not in light, not in radio, but in the very language of space-time itself, a single pulse of gravity, a report sent home on a journey of 1,000 years, a message we were never meant to read, and now the probe is gone. You can picture it in your mind's eye as you drift deeper into sleep. It is already far from us. It has passed the orbit of Saturn and of Neptune. It is crossing the Kuiper Belt, the realm of the ice dwarfs at the edge of our solar system. Soon it will leave the sun's faint warmth behind entirely, and enter again the great silent interstellar dark. It sails on, cold and perfect, on its new path. Its journey is long. For thousands of years it will drift, a lonely, patient pilgrim, towards its destination in the constellation Sculptor, towards the great gravitational anomaly, the secret door in the fabric of the galaxy. It is returning to the quiet, and you can return to the quiet with it. And back in the constellation Lyra, the great machine is quiet too. The Dyson swarm is dormant. It has done its work. Now it simply waits. It waits for the reply, the message from Europa, which is even now crossing the void at the speed of light. For 978 years that message will fly, a single, complex thought, carrying the secret of a hidden ocean. What will its masters do when they finally receive it in a future so distant we cannot imagine? We do not know, and it is all right not to know. Some questions are not for answering. They are for dreaming. What is the long thread that connects a flickering star to a hidden ocean on an icy moon? What grand cosmic story is being told across 1,000 light-years of silence? Let these questions go now. Let them be the gentle waves on a vast dark ocean, rocking you softly to sleep. Let them become a part of your dreams. The universe is vast, and it is ancient, and it is filled with a wonder that is deeper than any answer. And it is telling a story of which we are all a tiny, beautiful part. And the story will continue tomorrow. But for now, it is time for rest. It is time to close your eyes and listen to the silence, the gentle, peaceful, cosmic silence. Sleep now, sleep.